Hello guys, welcome to the channel. In this particular video, I will explain the problem K largest elements. The problem is really interesting and asked by companies like Google, Samsung, Amazon, Microsoft, etc. So let me talk about the problem statement. Here is the problem. It says that you are given an array ARR of n positive integers and an integer k. Your task is to find k largest elements from the array, and the output element should be printed in decreasing order. So one example is given here. Let me explain the example. We are given 5 elements here, and our task is to print the first two largest elements. So the first largest element that we have is 787, and the second largest element that we have after 787 is like 23, right? So this is going to be the output. You can even see here. I hope you have understood the problem statement. Let's talk about the solution now. So I have written one example, and before I will use this example to explain the approach. But before talking about the optimal approach, let's start with the brute force approach in brief. So after looking at the problem, the first approach that will come to your mind is like you can run a loop for from 0 to k. So while k minus minus is greater than 0. Inside this loop, you can find the maximum element each time. So you will have max equal to maximum element from the array, right? This array is the input array. And how you are going to find the maximum element? This is quite simple. Like you have a max which is initially equal to min value, and after this you run a loop, like you iterate over all the elements of the array, and then you keep track of maximum element, right? Max equal to max of the max that we have and current array element, right? This is how we find the max element. The complexity of this thing is O of n. So let me write the complexity along with the code. The complexity for this part will be O of n, and the complexity of this part will be O of k, right? And once we have found the max element, so you can see that, let's say I have found the max element at this point. So I'll simply add it to answer. So let's say I have an answer list here. I'll simply add to answer, and this is like answer dot add max element. Once we have done this, we can simply remove this element, because once we remove this element, then again we will find the max element, and then the max element will be this particular one, and this is the actual second largest element, right? So I can write this, my current max element, like array of max, like this is how we can do array of max equal to -1. And once we have done this, then we can simply find the next greater element in after the loop, inside the loop, right? So once we are done with this, then we will have our list as 50, 30, 23, like this. So we can simply return the answer. So I'll write return answer. This is what we can do in order to solve the problem. The complexity of this approach will be O of n cross k, right? So this is how we can solve the problem. Even we can reduce the complexity, so we can find this max element in an optimal way. How we can get the optimal way? So whenever we find the max element, then the first thing that will come to your mind is a max heap, right? Max heap. Max heap is a data structure that is used to get the max element in just O of log n time. But the condition is we have to form this max heap before like getting the max element each time, right? So how we can do this? Let's talk about this particular approach. So first of all, I'm going to write the example. Now I'm going to use this example. So I have 123, 12, 9, then 32, 50. So I have 1, 23, 12, 9, then 32 and 50. This is the array that we have. So for this array, we are going, okay, so let's talk in brief about max heap. So a max heap is a data structure that contains where like it is a tree like data structure. So let's say I have a structure like this. So the parent node will always have the max value, and the child node will always have the like smaller value. This is what a max heap is. And reverse is the case for a min heap. When we talk about a min heap, then we have minimum value here and then larger value here, right? So this time we are talking about the max heap. So let's move further. First of all, let me write the array, like tree representation of this array. So it is like array representation. Let me draw a tree with this array. So the tree will be something like uh, the tree will be 1, then we have 23, then we have 12, then we have 19, then okay, so it's not 19, it's actually 9, right? So I have 9 here, then 30, then 2 here, and then 50 here. So this is the tree representation. And in order to convert this tree, okay, so the approach will be, first of all, I will explain you how we form the max heap, like using this particular tree, and then I will try to write the code, right? So how we are going to form a max heap? I'm always okay, so like this is a condition for a max heap. The parent value should always be greater than the child value, right? So let's start with this leap. For this leap, we know there is no any child, so there is no sense of starting with the leap. Instead, we are only going to process the parent. So what is the first point where the parents start? You can see that this is the point, right? And for any array representation, the parent always start from the point n by 2 minus 1. So for this, the value of n is 7 and 7 by 2 is 3, 3 minus 1 is 2. So this is index 2, right? And you can see that 12, 23, 1, these three are the parents. So I'm going to process each parent one by one. How we can write this? How we can write this? Let me write this. Like when we talk about code, so it will be like for I equals to n by 2 minus 1, then I should be greater than equal to 0, then I is going to decrease by 1 each time. So this is how we can write this particular thing. We are going to process each node from n by 2 minus 1 to 0, right? Let's start with this 12. So for this 12, you can see that I have 12 here, then I have 50 as the right child and 2 as the left child, right? So what is the largest value among these three? Largest value is 50. So simply like bring this 50 at this place. How we can do this? Simply swapping. So it is like 23, 9, 30. This part is going to remain same, right? So here I will have 50 now, and then 2, and then 12. So this is how you can see that this particular part is following the property of max heap. Similarly, once we are done with this part, so we will come to this 23. So for this 23, I'll do the same process, and when I do so, then I will have this 30 at this point and then 20 at this place. So it is like swapping these two values. So I have one here, then I have 30, 50s like here, and then 12. This part is going to remain same, and then I will have 9 and then 23. You can see that now both child of this particular node, like both child are following the property of max heap, right? But not this particular node. So now let's try to solve for process this particular node, which is one last node. So you can see that 50 is the largest value, so I'll do 50, then 30 here, then 1 here, then 9, then 23, then 2, then 12. I wanted to observe one thing here, that of course, the largest value is at this point, but this tree is still not following the property of max heap. The reason is when I swap these two nodes, then this part has been broken down, right? So I have to correct this part again. How we can correct this part? I can simply process like we do before. So 12 will come here, 1 will come here, and when we do so, then the final heap will be 50, then 30 here, then like 12 here, then 9, 23, then 2, and then 1, right? So this is the final heap that we have. So inside this loop, we are going to make a function. So it's like a process function. So I'm going to name this function as heapify. This heapify function is going to heapify every node. So it is like array I and then n, right? So it is going to take I as the parameter. Why? Because the ith node is the node that we are going to process, right? So now let's talk about the heapify function. For heapify function, you can see that we have three nodes. We have current I node, then left and child, right child. So whenever we have the ith node, I node in array representation, then the left child is always 2 cross I plus 1, and the right child is always 2 cross I plus 2. This is very important thing, guys. You should memorize this thing because this is going to used in at various places. So it is like left child and this is right child. Now let's try to implement this particular task. So we have a heapify function. Let me write it. I have a heapify function. Heapify is going to take array, then I, then n. And inside this function, I will have, first of all, I will have the left child. So left child will be 2 cross I plus 1. And right child will be 2 cross I plus 2. And after this, I need a element which is largest, right? So let's say this is largest and this is currently equal to I. Now I'm going to check whether this largest, like I is the largest, or we have left or child as largest. So let's say I have this current node here, then it will have two child. So I'll check if my left left is greater than n, and array of left is like greater than array of largest. In that case, I need to replace the largest. So I'll say that okay, now my largest is the left element. Similarly, I will check for right element. So if my right child, like right child is greater than n, and array of right, like right is greater than array of largest, in that case I will say okay, now my largest is the right child. So I hope this makes sense to you till now. Once I have got the largest, so let's say I have got the largest, this is my largest, so I just need to swap these two elements, right? So let's talk about this particular example. I have got the largest, I will simply swap these values. So let's do it. If my I is not equal to largest, what does this mean? This simply means that let's say I have initialized my largest with this particular node, so there is no sense of like swapping I with I. So I'll always check this particular condition, and once this condition is true, so I'll simply swap ith node and the largest node, right? One more thing is here, that why I am checking this condition. So I know that my left child is always 2 cross I plus 1, but for this, let's say I am at this place, so 2 cross I plus 1 for this will be out of bound. You can see that it is greater than n, so I always need to take care of this condition. That's why I'm checking here, right? So after this, once I have swapped the values, you can see that here I have swapped the values, right? So I have got 1 here. So now I have to process this part again, so that the like tree sustain its property of being a max heap, right? So what I'll do is I'll again call the function, same function, it's like recursive function. So heapify, what I need to heapify the current largest element, so array, then the current largest, and then n, right? So you can see that the largest was this particular place, and then I'm calling for this place. Now let's talk about the time complexity. So the time complexity of this function is going to be O of log n. Why I'm saying that? Because you can see that when we have n elements, then we are forming a tree out of these elements, and the tree always going to have log n height, right? This is again a different derivation for this, but for now you can just memorize this thing or Google this thing in order to understand better. Fine. So now as I have like made the max heap, so all I need to do is okay, so all I need to do is just make the max heap, and then okay, so first of all, let me write this max heap. The max heap was 50, 30, 12, then 9, 23, 2, 1. So the max heap is like 50, 30, 12, then 9, 23, 2, 1, right? This is the max heap. For this max heap, I know that the first element is always going to be the largest element. But this doesn't mean that this is the second largest or this is the third largest. No. So this is the largest element. Now what I'll do is I'll make an answer list, and I will run a loop while my, okay, we can run a for loop here as well, doesn't matter which loop do you use. So while my k minus 1 is greater than 0, answer dot append or answer dot add both means the same to me. Okay, so I'll do array of 0. Array of 0 is the first largest element, so now I have added 50 here. After this I need to remove this 50, so I simply make my array of 0 equals to -1. Once this element become -1, then we again need to call the heapify function, so that this particular element becomes okay. So this particular element comes to this place now, because this is the second largest. So this way I will have 50, then 30, then 23, right? So this is how we can solve the problem. Let me show you the code in order to explain better. So this is the code. On the left hand side I have the Java code, and on the right hand side I have the C++ code. So you can see that for the Java code, like first of all I am building the heap, and then build heap simply means this particular thing. This is O of n, and this is O of log n, and this is again doing the same thing that I have explained you, and this is the C++ code. If I talk about the time complexity, then the time complexity will be O of n log n plus k log n, right? This is the complexity. So this is how you can solve the problem. I hope you guys are able to understand the solution, but we can do some optimizations here. The optimizations that we can do is, of course I have not done those particular optimization. You can I'm going to, like, this is the approach that we have, but the optimization that we can do is, instead of forming the, like, instead of processing all the elements, we can process only key elements. So it will be like, I have for I equals to 0, then I smaller than n, then I plus plus. This is like adding all the elements in a priority queue or max heap, right? But whenever the size of max heap becomes greater than k, so I need to remove the element. It is like max heap. Okay, so let me remove this. Instead, I'll write something like this. I'll write if heap size become equal to k, only in that case I need to pop the element, pop the zeroth element, and then I have to, like, push the current element, push array of I, right? And if the size is not equal to k, like smaller than k, in that case I can simply push the element, array of I. So this is going to optimize the like solution a lot. What it will do is, it will make the solution O of like n log k. So this is like a really good complexity, right? So this is also a very good solution, even better than the solution that I have explained you. But you need to like, you need to understand the concept of max heap in order to solve this problem. So this is all about this video. I hope you guys find this video helpful. Thank you.